Okay, so if you really understand the basics of logs, you'll be able to convert these into exponentials, which have an x in the exponent. You can do that in your head and figure out the answer. All right, starting over on the left-hand side, Mr. T. 5 to the x equals 25. You're right. And then what's x got to be? X got to be 2. Good. Next one. Let's go back to Mrs. M. Ms. M. Sorry. And that means x would have to be what? Not 1/5. You want the square root of this, right? There you go. So x has to be 1/2. That gives you a square root. And probably 2. Okay. The next one. Let's go with Mr. W in the back. Set up the exponential for me. Yes. Can you do that one in your head? You got to get that thing to flip. What's going to make it flip? Got to put a negative there, and then to get it to go up to an 8, you need a 3. You're right. So it needs to be x equals -3. Okay. And the last one. Mr. R.
You'd say 1 for that. I mean 3 to the x.
3 to the x equals 1/9. Good. And then what?
Then you flip the 1/9.
You need it to flip, so that means my x has got to be negative, right? And then what?
And then you flip -2.
There you go. 2 would make it square it, make it up to 9. The negative makes it 1/9. All right. Just a note on homework. We're not grading the homework that we would normally grade today because the answers weren't available online, unless you were smart enough to know where to look. Did anybody find it? In the archive. Yeah, see it. Whenever I'm gone, there's a chance that you can find it in the archive. Yeah. Okay. So tomorrow, we're grading both of them. The one I'm giving you today and the one I gave you over the weekend. Okay, so be ready for both of them. And I will post both answer keys on the normal front page tonight. All right, moving on. That is more concrete because you can see the numbers and it's easier to like understand it. This is more abstract because it's all in variables. Okay, like here, if I asked you what's the slope on this one, what's the slope? 2/3. What's the y-intercept? 7. Good. And in the more abstract, the slope can still be found, but it's a variable. What is it? M, and the y-intercept is b, and so they're just a little more abstract. Well, this is much more abstract, but basically, if you read it through, all it's saying is that when you're doing a log, you can take this to the that, and it'll equal the other thing. Okay? B to the y is equal to x. And though the devil is usually in the details, and this has a little details down here. I don't know if he discussed with you when he first introduced this to you when the sub was here Friday. B and x are positive numbers, and b is not equal to 1. What that means is, if you ever see a problem where the base is a negative number, or the argument is a negative number, your answer is automatically the empty set. There's no possible answers. That'll save you a lot of time. Big, long problem, got a negative in the wrong spot, oop, no answer. Know what I mean? Save you a bunch of time. All that pain and suffering of trying to solve it the long way. If you just notice that either one of these are negative, it's not possible. The other thing it can't be is this last part. B is not equal to 1. So that means the base right here can't be 1. And that's the reason for that is that then the base here would be 1. And that means 1 to a power has to be something else. Well, what do you know about 1 to a power? That was 1. Even if I put it to the 0 power, still 1. What if I put it to the -1 power? Still 1. Okay, it's always 1. So you can't do problems where the base is 1. So bottom line is you're not allowed to do it. Yes, you could get an answer, but you're not allowed to. So don't let that be negative, don't let that be negative, and don't let that be 1. Okay? And if they ever are, then you have an automatic answer. Empty set. Yes. You can't, it's just a definition of a log, it's not allowed. All right. If we had more time, I could take 15 minutes and talk through examples and stuff, but that just takes a long time. Okay, evaluate these. All right, remember how I said that this number could never be 1? I didn't say that about this number, though, did I? I said that number could, I didn't say anything about how it couldn't be 1. Like, that one can't be negative, but it could be 1. But watch what happens. If you want to figure these out, you always say equals x. And then you can reason it out using exponential, right? And I'd say what to the what equals what? A to the x has to equal 1. Just think. Think about it. What's x? The only thing that will work consistently is if x is equal to what? 0. If x is equal to 0, then everything will always turn out to be 1. So this has to be 0. So if x is equal to 0, then that equals 0. And that means I could put a 0 right there. Which means that no matter what, if there's a 1 right here, notice that's a variable. You can put anything you want in the a spot. If there's a 1 in the argument, the answer is always 0. So log, here's one that looks really complicated. Base 2.57 to the 1 is equal to what? Automatic, 0. Okay? So what I'm showing you right now are properties where if you know the property, it can save you a lot of time in reasoning it out. This one, it's always equal to 0. Anybody want to take a shot at what that one's always going to be equal to? 1 is right. Let me prove it. How can you reason it out? You say equals x, and then let's make it an exponential. What to the what equals what? A to the x equals a. Think about it. What's x got to be? 1. So it's always 1. I wanted to reason it out with you. I don't want to just say it's always 1. I want to show you why. Okay, you can reason it out by saying it equals x and then solve it with exponentials and stuff. But now, bottom line is, whenever you see log base 10 of 10, what's the answer? 1. If these two are the same, then the answer is 1. All right. What's the answer? Nope. All right. Then, how do we reason it out if you don't know the property already? Once you know the property, this will be easy. You say it equals x, right? And you say a to the x equals a to the x. What the heck? That means when I put x there, I made a true statement, which means it'll work for anything that I put in for x, which means that the answer is just x, which means if you had log base 9 of 9 to the 12th power, what would the answer be? 12. You see? This part right here would be your answer. Or log base 5 of 5 to the 3rd, what's the answer? 3. And you can, don't let this just be just totally just guessing a number here. You can always set it up and say equals x, and then say 5 to the x equals 5 to the 3rd, so therefore x equals 3. But it is a property, so you can just say, oh, these two are the same. There's the answer right there, 3. All right. This last one is going to blow you away. A to the log of a of x. Now, I said that wrong. A to the log base a of x. This is an exponential with a log in it. It's a mind bender. But remember, whenever we have these, I said you can always set it up and say, I don't know what it equals, so I'm going to say it equals x, right? I could put any variable right there, but I'm going to use x. And now, remember how you write a log from an exponential? You start by saying log base, and what's the base in this one? There's the base. Log base a of, and then you don't take this stuff right here, you go over here, of x is equal to, and then you go back over here, log base a of x. Log base a of x is equal to log base a of x. That means I made a true statement, which means that x really has to equal x, which means that the answer is whatever x is. Just like on the last one. So if these bases are the same, that's where the answer is. So that means if I have 5 to the log base 5 of 73, then what's the answer? 73. And again, if you want to prove it to yourself, say it equals x, and then set it up and say log base, there's the base, 5 of, go over there, x is equal to, go up in there, log base 5 of 73, and then look at this. Log 5, log 5. X has to be 73. See? So you can do it the reason it out way, or you can do it the property way.